you please explain a little bit about your current project role and responsibility?
Okay, the last project what I worked on was for an oil and gas company. That was uh, a requirement from a client. It was like to continuously monitor an oil production well. There are certain instruments through which the data gets collected and then it gets stored in an industrial database. So I had to continuously monitor that data. There were some physical parameters provided. So every 10 seconds, if those parameters are violated or some of the moving averages, if it gets violated, then an alert has to be triggered back into the system. And also forecasting has to be implemented for that particular system, like a forecasting of the oil outflow or the production output. So that's the high-level overview of the requirement of the project. And the final solution was deployed as an application on the production server. So that's how it involved.
Okay. Okay, so could you please tell me the differentiate between inductive learning and deductive learning?
Deep learning and detective learning.
Inductive and deductive learning.
Okay, inductive and detective. Um, Inductive is something I'm hearing the word or terminology as new, but I I guess it's more of descriptive statistics or analysis of the existing data. That's what I feel is for inductive the terminology, and detective learning is using the past history of data and then predicting the future. It's more of predictions using regression and classification algorithms.
Okay, what is deep learning and how it is different from machine learning?
Uh, Machine learning and deep learning, the outcome or the underlying task is mostly same, but it differs by based on how it achieves the outcome. In a machine learning, most of the algorithms work based on some statistical tools or mathematical problems. Like we can call it as deterministic, sorry, not deterministic, like stochastic processes or probability based processes. But in a deep learning, it's purely going to be making use of neural network based algorithms where a network is formed and we define layers of networks and we connect together, and then that particular network learns the input patterns and then it remembers what it has to pass through every layer and finally predicting the outcome. So that's why I mentioned the task, underlying task is same, whether it can be a prediction or a classification task basically. But how it achieved is different from machine learning and deep learning. That's my viewpoint.
Okay, so do you have any idea about TensorFlow?
Yes, so TensorFlow, I have used it by making use of the Keras interface, which is comes from the TensorFlow itself. So we can create neural networks and achieve processing numbers. Like it can be a pure integer based data set or uh, a language based data set, or it could be an image or any kind of it. But ultimately, that particular data set is read into its specific numerical format, like encoded into a numerical format, and then the network processes it.
Okay, all right. For example, you consider you have a raw text data, right?
Okay.
And
Uh-huh.
the explain text pre-processing steps.
Uh, Text data. Okay,
Yeah.
I heard tax. Got it. Um, okay, in text data, first of all, the complete text needs to be uh, broken down into something called as tokens, which are individual words reduced to its base form, like eat, ate, eaten, eating. All these words will have a base form, like say EAT. So these are going to be generally taken as tokens in a language, and all these words, all these base words together, we also prepare relationship between all of these words. That particular relationship is called as an embedding layer. So this embedding layer is something not we don't have to create it every time for our project. There are embedding layers created and made available by research companies or research projects, mostly from universities, and Google offers a lot of embedding layers. Like so, that will have the all the common base words or tokens linked together so that we can identify. So if I just type eat, in my program, I just train with the word eat only. But whereas in real time, someone types eating or eaten or whatever it is. But because of this embedding layer that we are importing and using it, it can understand the same word I am using it there. Um, and finally, these are intermediate layers, I can say, the embedding layers or the input tokens. So any neural network, before that, any neural network is going to consist of primarily three different steps: input layer, output layer, and in the middle, there can be either one or multiple layers of networks. So not going into detail of what these input, output, or multiple in between layers is going to consist of, but we can assume, or ideally we can consider it as like input, output, and the in between process. Just an abstract system. There is going to be some input and process and output. So the in between neural networks is going to be one is the embedding layers that we can introduce, and followed by that we can have multiple other raw layers, like we call the layers which can process integers. Some of the activation functions like RELU or uh, log functions. Those things we keep it in the next coming layers, and finally we also say what this particular text should be relating to. Maybe I will take an example like a sentiment classification. From the text, if I want to classify that particular text as a toxic content or a not toxic content, then I will have to give a past history of data, some paragraphs, some reviews, and then I also should say what these reviews are, which are toxic, which are not toxic. So based on this, the final trained network will contain the optimized weight information so that it can classify a given text as toxic or non-toxic. So this is one example for text processing text data.
Okay, all right. So my next question is to you. What is significance of data pre-processing, and what are the steps of data pre-processing?
Okay. I'll take the example of this particular text data itself. The significance of text processing is primarily the data can be coming from any source. So from multiple places it can come, or even from a single source. When the data comes into the program, it can have a lot of variations or unexpected behaviors. Like sometimes the data comes out, some features might be missing there. So that is where, while we give input into our system or the process where the network is going to start process there, or it can be a simple machine learning model, a statistical based model which is going to process our data. The entire data that we give into the process has to be clean. So clean by meaning there should not be any missing information either in the feature wise. Say we consider, let's 5 inputs we are going to give into the process. Then all the 5 features should be present there. If something is missing there, then the process cannot understand what the input data is as. That is where the pre-processing steps comes in. In the pre-processing, we analyze, we remove all the missing information, unwanted data. If possible, we also go and do a replacement for the missing information by general behavior observed. Either we can replace it with most commonly repeating words, or it could, if it's a numerical data, we can replace it with mean, median, or mode of the particular information or a feature. In a text processing, in a text data, there are certain steps of pre-processing. Like we can say reducing the words into its root forms. We can truncate the words towards the ends. These have terminologies like stemming, lemmatization. Stemming is reducing words to root forms. Lemmatization is again reducing it to root forms by making use of language-based models. Using language-based grammar models, we can reduce it to the words. So these like stemming, lemmatization are all part of the pre-processing step, I would say.
Okay, all right. My next question to you: what is Bayes theorem, and how is it useful in a machine learning context?
What is the best theorem?
Bayes. What is Bayes theorem?
Based Bayes theorem. Okay.
Yes, yes.
Uh, yeah. A Bayes theorem is I've used. Um, there is a Bayesian probability which says the future is dependent upon the past probability of events are occurrence. So that is the underlying base principle. So it will have three different probability measures, which using which we predict the future probability of occurrence of a particular event. That is primarily to it's used more in a classification algorithm based classification algorithm is available which makes use of this theorem, and we predict a probability score between 0 to 1 for in this particular prediction model, and based on the probability score we take the highest probability as the outcome, and previous existing probability of categories we can say those are nearby occurrences or something, like we can also make use of it as recommendations by the base algorithm.
Okay, all right. Yeah, so this interview discussion for machine learning engineering interview preparation. So the question and answer round we just discussed. So I hope this round of discussion and this interview discussion will be helpful those who are preparing for interview. So thank you for watching my YouTube channel, and don't forget to like and subscribe my YouTube channel to get more video like this. So stay tuned to get more video, and I hope whatever the interview round of discussion you can go through all the details, and I hope you will crack the interview. So all the best for your interview.